again. Okay. Now think about this program. I think about program here. I want to use a program. I want to use a program here. After I want to. Yes, I want to say hello. Between now hello. Now think about this one. If I want to do it hello for 10 times, I can do it 10 times or 5 times. 3, 4, 5. What? And what happened there? I have to do it for 100 or 100 times or 1,000 times. I cannot manually do that, right? So in that way, you have to use the loop here. The loop is the action that to do the repeat action again and again and again. Repeat the action again and again. And in order to exit the loop, remember that you always have to condition to exit the loop here. As for each iteration of the loop, come back to check the condition. If yes, keep doing it. If yes, keep doing it. And if the condition is not correct, exit the loop. And remember one thing again, I have to mention it again. In the router, when the condition true, you exit the loop. But in the real life, in the real pseudocode, in the pseudocode or in the real programming language, whenever condition true, keep doing it. That's why when you convert from the pseudocode to the router, remember one thing. When the condition true in the router, you exit the loop. But in the pseudocode true, keep doing it. In the real programming language, keep doing it. So now for this one here, I do not have to do it again and again for 100 times or 1,000 times. I use the loop interrupter here. In the loop interrupter here. So think about this one. I want to print it out hello for 10 times. No, I need to 10 times. So for this one, it is a definite loop. Definite loop, that means you know for sure how many times you want to run it. At the beginning, before the loop, how many times, right? So now this is, so normally for the definite loop, you have to maintain the counter. Remember that you have to maintain the counter and you have to initialize the counter before the loop. That's the thing. Now think about this one here. I have to initialize the counter. I have the counter here. I put a counter, whatever. I put number 0, number 1 here. So now see, for each iteration of the loop, I want to print out the hello. I want to print out the hello. And the condition here, whenever the counter greater than 10, I exit the loop. Whenever the counter greater than 10, I exit the loop. So see, I just keep doing it, keep doing it. Now, any comment for this program? Any comment?
The counter is
1. The counter here, if you stick to this program, the counter here always stay at 1. Right? See, the counter here stay at 1, right? So do it again, print hello, and the condition here, you see. The condition here for this program, the counter here always stay at 1, and the condition here, it never being true. Right? That's why keep it doing it again and again. It's endless loop. It's endless loop. So basically, for every loop here, you have to initialize. Condition. For this one, initialize condition counter number 1 here. So in the body of the loop, you always have to action to alter or the change the counter here. Otherwise, it always stick at number 1 and keep doing it again and again. See, now let's look at the program here. If you look at this program here, right? I see, I can run it here, right? See, it run it forever. You see, the reason it runs forever because the counter here always stay at 1. And when you check the condition here, it never ever greater than 10, right? That's why keep doing it, and keep doing it. Right? And you can do the same in the Python also. We'll go here, right? So in the Python, you can think about this one. They have the counter here. 1, right? Y counter less than 10. Y counter less than 10. I print hello. Yes, the same, right? You see, initialize the counter before the loop, right? Check declaration. If the counter less than 10, keep doing it less than or equal. Right? Keep doing it here. And what happened here? Okay, I have this one. I have the endless loop. Let's stop here. Okay, see, it run it forever. I keep doing it, run it forever. And of course, I want to terminate so that you see it. Let's stop it here. So that's the thing. Remember that when you work the loop, you have to initialize. Normally, it's a definite loop, right? Definite number of iterations. You have to initialize the counter before the loop. Right? Check the condition, and inside the loop, you always have the action to change the value of the counter. Otherwise, it will be the endless loop here. Now come back to my router. How can I modify my program to avoid this program? What do you think? Is the router here? How can I modify it?
You can make it.
Yes, each iteration I increase the counter by 1, right? So in order to do that, very simple here. I just put it here and create it. I have a counter equal to counter plus 1. So now I run it again. Okay, so you see, I have the 10 tab here, right? I have the 10 tab here. Okay, so see, by using the loop, right, you can use it to do with every repetitive action here instead of manually print out the hello for 10 times here, right? That is the benefit of the loop here. So now come back with my slide. So basically, that's the loop, right? Advantage of the loop. That's what you learn, right? You see, you can do the one action, but you can do it again and again instead of doing manually here, right? Using the loop control variable, nested loop, avoiding the loop, a common mistake, using the for loop, using a post-stat loop. Okay, now think about this one here. Looping makes computer programming efficient and worthwhile. You can see that, right? Instead of doing it again and again and again, it's very easy for you to make a mistake and you have to consume a lot of time. You just do it one time and let computer do it again and again and again for you. Right? You can write one set of instructions to operate on multiple separate set of data, less time required for design and coding, fewer error, and a shorter compile time. Loop is a structure that repeats action while some condition continue. Remember that. In order to do the loop, you always need the condition to check. Right? In order and decide if the condition true, keep doing it. If not, exit the loop. Okay, so that is the structure of the loop, right? You have the new alternative here. Check if the condition correct. Come back, do it again, and do it again. And you see, it's the mainline logic, right? You have a housekeeping, and in that you have to loop here. Loop here, keep doing it for the first employee, the second employee, and third employee, and so on. And see, that is the mainline logic here. See, you break it down the housekeeping. Right? Now we've got the initial value. Check the condition. If true, keep doing it again and again and again. Okay, so as long as the condition remains true, the statement in the while loop body will be executed. Right? Will be executed here. Now, So sometimes, right? Sometimes you think about if you want to do it and you want to count for how many times you maintain the counter here. Right? The counter loop control variable initialize. Remember that before the loop. That's the counter I set it number one before the loop. Right? What happens if I put it inside the loop? Now think about this one here. Think about this one. What happens if I put it inside the loop? What happened? What happened? What do you think? What happened?
It will reset the counter.
Yeah. So every iteration again it resets the counter number one. Again number one. So again the condition here never and do it again and again and again forever. Right? You do it again and again and again forever. That's why I see when the loop, remember initialize the counter before the loop. Right? Before the loop, not inside the loop. I see for this one here, right? You run it. Okay. See the counter here. 1 and 2 reset to number 1, 2 reset to 1. Right? See, or you can run by step here. And 1, create it here. Hello, counter 2, right? Again, come back, reset to number 1. See, that's the process here, right? So that's why. Remember one thing: the counter initialize before the loop, outside the loop. Okay, each iteration loop control variable is that is condition here, right? And in the router you can see I change the condition if the counter greater than 10 or not. That's the condition, right? Each iteration you have to check it to determine if you want to continue or exit the loop. Now it's very important here. Body is the loop, you must alter or you must change here. You see, if I do not increase the counter by 1, it stays at 1 forever and it's loop here. Right? That's why the body of the loop you must change it here. Right? And the repetition here, it can be controlled by the counter or it can be controlled by sentinel. Then the sentinel value. I talk about what is the sentinel value later in this class here. So remember here, one thing here. Remember one thing here. You must alter the value here. So it doesn't matter. You can decrease or increase whatever it is. Now think about I can do the same program here, right? I want to do it at 10 times. I want to do it 10 times here, but instead of starting from the number 1, I do it at 10 here. I do it at 10 here, and I check if the condition it is less than 0. Right? If less than 0, correct. I see it. Right? If not, every time I decrease it. Okay, I do the same. Right? Do the same here. Now starting from 10, the next one 9, 8, and until number 0 here. You do the same. Okay, I see. Initialize the counter before the loop, outside the loop. Check the condition, and inside the body of the loop, always has action to change the counter here, the change of the condition here. Right? Otherwise, it will be the end loop. That's all. Right? Okay, now it's a loop. It's a loop. They break it down into 2 types loop. The first one is a definite loop with a counter. Definite loop is a counter. That means you know for sure how many times you want to do it. Just that you think for the example here, you want to print it 10 times. Right? Now the definite loop execute predetermined number of times. And normally in order to do that, you have to maintain the counter here. And the counter controls the loop or the counter loop. Right? And the program counts the loop repetition. Right? And loop control variable can be increased or decreased. As I give you an example here, right? Starting from 0, increase to number 10, or starting from the number 10, decrease to number 0. The same. Right? And counter any numeric number, count number time, and normally start with 0. You want to do it 10 times, start from 0 to 10. And of course, you can do it from 10 to 0 here. I think about this one here. This program here. This program here, you want to print out hello 4 times. Right? You want to print out the hello 4 times here. So see the condition. You see, always follow the same rule. Right? Always follow the same rule here. Initialize the counter outside the loop. check the condition. Have action to change the color. That's all. Remember 3 steps here. Right? 3 steps. 3 steps here. You won't have to follow the same rule here. Now, that is a definite loop. That means you know for sure how many times you run before the loop. But sometimes you work with an indefinite loop or indefinite number of iterations. Now think about here. You perform the different number of times each time the program executes, and the user is the one who decides how many times the loop executes. Right? Think about here. In the previous example, right? I do it for 4 times, but I want to change it. So I want to keep doing it until I press no here, right? So maybe one time I can execute it for 2 times or 10 times, whatever it is. It doesn't matter, right? So you see, by this one here, right? By this one here, I can change this one, right? I can change the program here. Now I have the continue. I set it to the experience. So now the condition, I check the condition. Continue. Equal to. Now I exit loop. Continue, no. If not, I do it here. Now see. Again, what's wrong with this program? What's wrong with this program? What's wrong with this program? If you look on this one, what's wrong with this program?
There's no change to the counter.
You have no counter here. What do you think? Now again, this one also, this is endless loop, right? The thing is that here. The thing is that here, you see, the continue here is yes, right? The y, sorry, the continue is y here. You check the condition, it never equal to n here. That means we need again, and again, correct. So now, in order to do that, remember you have initialized the variable, not the counter. Counter is for the definite loop. This one is a variable condition here, variable condition. Again, initialize it, check the condition. Have step to change the condition here or get the new condition here. Right? Let's see. In order to exit here, so let's see for this one here, right? I can modify it here. I can modify it. I get input. Enter yes to continue. Or and to exit. And I store it into the continue variable. Okay. So now what happened here? For each iteration, okay, you want to yes or no, right? And store it in the variable name continue, and come back to check and see if I run it again. So now, if I want to run it for this one, I want to run it 2 times, and I want to yes. Now, one more time. Now I want to terminate it. No. See, I have 2 times, right? But next time I want to do it 3 times. It's okay. Next time I want to do it 1 time here. Now, yes, 2 times. 3 times. No. See, so that is an indefinite number of iterations. So the user is the one who controls how to terminate it. And see, so basically that in short, you have 2 types of loop. The first one is a definite number of iterations. And normally for the definite number of iterations, you maintain the counter. And you know for sure how many times you want to run. But in the indefinite number of iterations, you maintain the conditional variable. Right? That is a conditional variable. Okay, you initialize it, check the condition, and inside the loop, you need to get action to change it. Otherwise, it ends loop. Right? Okay. Okay, the code is a sentinel value. That's the one who get it to terminate the program here. Okay, so again, it's very important. You have to understand the structure of the loop here. In the mainline logic, right? 3 steps occur in every branching loop here. Provide starting value for the variable that control the loop. Now, what is it? Control the loop here, variable control the loop here. Remember, in the case of definite iteration, it is a counter. Right? But in the case of indefinite iteration, it is sentinel variable here. Right? That is the variable here. Right? And the setting the loop control variable. Right? So it check the counter or check if you want to read or no. Right? And so only have the action to change the control loop variable within the loop here. Otherwise, it means the end loop here. Right? Okay. Any questions so far, guys? Okay, so here, this is a mainline logic example here. Right? You can see. You can clearly see here. Mainline logic. Right? Right, so see this one, right? This one is now let me look at the program here. Okay, give you the gross. Okay, and okay, figure out what is the deduct. What is you got the you got the name, you got the gross, right? So figure out the deduct, and from that figure out the net income and print out the name, gross, deduct, and net income, and move it to the next employee here. Right? So this one you keep doing it program for many employees. For each of the employee, you need to enter the name, you need to enter the gross, and figure out what is deduct, figure out what's the net income, and print out name, gross, the deduct, and net income here. I see that is mainline logic here. That is the mainline logic. You have the housekeeping. See for this one here. You have the housekeeping here. You see in the body of the loop, right? In the condition here to choose the loop here, condition to exit the loop. If we check the name equal to quit or not, quit, what is the quit here? Okay, right? If not, like you see, not equal, that means you keep doing it the detail loop here, right? If not, sorry, if equal, you exit the loop here. So what is the detail loop? You see, you would gross, figure out the deduct, net income, the output, and of course, you see, if you want to move to the next employee, you need to get the name of the next employee here. Right? That's the mainline logic here. Okay, so just keep doing it here. So see on the if you work with the raptor, see I break it down into the housekeeping here. The housekeeping actually is to get the name of the per employee only. That's the most important thing. Get the first name of the per employee in order to go to the loop here. Because in the loop you need to know what's the name to check if the condition equal to the XXX here or not. And the detail loop, get the gross, get the rate, deduct, net, print out, and get the name of the next employee here. And end of job here. So when you run it here, it's very simple for this one. Then you see. 5,000 here. Now enter the name. Okay. Now, if I want to access, so that's the program here. It follows exactly the same mainline logic. You have the housekeeping, you have the loop, and you have end of job here. And you could do the same with the Python also. The Python you follow the same thing, right? You can think about housekeeping here. You need, so you see, it's very structured, right? It's very structured with the loop here. You can clearly see here. That is a variable to control the loop. Variable to control the loop. and the condition of the loop here. Alright, that's the condition. Now, variable to control the loop. I'll see. You do everything. Now, the third step inside the loop, we have the action to change the value, the control variable here. Right? Make sense? See, get the first one, initialize it. The first one, do everything in the loop, have the action to change the control variable here. If not, if you delete here, you do it again forever for the same employee. Make sense? Okay. Now, sometimes you know that in the selection you work with method selection, right? You use a combine condition here. And you use the and or you net it together. The same as the loop here. The loop, and so we need to loop within the loop here. Right? And in that case, you have the outer loop. Right? Outer loop is a loop that contains as a loop, and the inner loop, that loop is that totally inside the other loop here. Right? And netted when value of two or more variable repeated to produce the same combination of the value here. So think about this one here. Think about this program, right? In this program, what is the program here? Okay, this one is a quiz and answer for this one. So let me see. Number part 1, 2, 3, 4, 5. Okay, now see what this one here. For each quiz, right? For each quiz, you have the 5 part here. Now that's why you have the 5 part here. Right? You have the 5 part. Right? And for each part, you have the 3 questions. You can think about this one, right? You have for each of the exam here, each of the exam you have the 5 part, and for each of the part you have the 3 questions, right? So in totally you have how many questions? In total, you have how many questions? 15. Right? So you can think about this one here. Whenever you work with the netted loop, you can think about work as a magic here, right? You think about this one here. Let me create here. Where am I? This one? Share screen. Why won't it? I can think about this one. Okay, so we can think about here. You have part 1, you have part 2, part 3, part 4, and part 5 here. Right? You can think about that is the row. For each part, you have 3 questions, right? So we have the question number 1, we have question number 2, and have question number 3 here. Right? Okay, so now in order to print it out, you do the netted loop. You do the netted loop here. The outer loop is the part here. You're starting from the part number 1. And remember that for part number 1, you have to print out 1, 2, 3. That is the inner loop. Right? So the question here, 1, 2, 3, is the inner loop. And the part here, 1, 2, 3, 4, 5, is the outer loop. So what happened here? For each of the part here, you have everything 1, 2, 3. When you're done with the inner loop, when you're done here, think about that. 1, 2, 3 here. When you're done with the inner loop, what happened? You exit the inner loop, you go back to the outer loop, you move to the next iteration of the outer loop. And again, you do 1, 2, 3. And done it, go back, move to the next one. That's the process of the working netted loop here. Netted loop for this one here. Now, come back to this one, right? Come back to this one. How it works this program here. Now see what's this program here, right? See. If you look on this one here, you have a part counter number 1. Part counter number 1, right? That is initialize the counter. Initialize the counter here. So what happened for this one here? What happened for this one? If you look on this one here, you can clearly see here. You can clearly see for this program here. You can clearly see program. See, this is the loop, right? This is the loop. So how about this one? another loop. Right? Because it condition here come back, condition here come back. So this loop here totally put it inside the other one. It is negative loop here. And you see what's the inner here? Inner you have the question counter, everything from 1 to 3. So when we done with 1 to 3, you see when we done with 1 to 3, what happened here? If the condition is true, right? What is the condition is true for the no? Yes, here, no. So when it's no here, right? You exit the loop. You see, you come back to the outer loop here. You do the next iteration of the outer loop. You make sense? Okay. So for this one, you see, you have netted loop. The question counter is inside the part counter here. I see. For each one, you do it 1, 2, 3. If it's 3, exit it, go back to this one, and move to the next one. And for this one, you do it 5 times. This one, you do it 3 times. So in total, you do it 15 iterations. 15 times. Right? So in order to do that, in the interrupter principle here. Right? In order to do that, interrupter principle. It should be better. I do not use it. This one. Okay, so that's the program. Let me. So see, that's the program here, right? You can clearly see it here. You can clearly see the interrupter here. Now, Z1 is a loop. Z1 is a loop, inner loop. You print now every question from 1 to 3. And see, this one put it totally inside the other one here. That one is outer loop. Outer loop. See? This is print out the part here. Now, with it, now let's look at the inner loop. What happened here? Let's look inner loop. It always follows the same rule here. Now, if you have to focus it here. You see the inner loop. If you look on the inner loop, initialize the counter. Right? Now, check the condition. It greater than number 3 here or not. Right? Now, print now, do something. Have action to change the counter. That 3 steps of the inner loop. Right? Okay. If you look on the outer loop here, what happened here? If you look on the outer loop, what happened here? Outer loop, what happened here? Outer loop, what happened here? Initialize the counter before the loop. Check the condition. Right? Check the condition. And at the end of this, you can see, at the end of the loop here, you can see. This one here. This one here. Right? This one here. Do it again. I think I do not need the 40 and the 2 not. So okay. So now I run it here. I run it program. I run it program. You can see it clearly. And the quick name. So we see, if you look at the program here, right? If you look at the program, that is outer loop here. Part number 1. For each of them, do it 1, 2, 3. Move to the outer one. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Right? So that's the process. That's the process here. Now, you have to remember that. You have to remember everything. Set is same in the same chapter here. You see, starting initialize the counter. do something, change the counter. That's the outer loop. That's inner loop here. Initialize the counter, check the condition, change the counter. Right? Okay. Any question for this one? Okay, good. You can do the same with the Python here. Right? You can see in the Python also. In the housekeeping here. In the housekeeping, you get the quick name, right? And you need to check the condition of the loop here. You see, you have the netted loop, right? That's why you have y here. Right? The inner loop, you have y here, the outer loop here. Right? Outer loop here. Now see, for this one here, you see, I have to keep doing it, right? That's why I have the housekeeping, the quick name here. That's why I have something to check the condition here. Right? Checking the condition here. If I want to go again, I need to change the counter condition here. And so basically for this one, you see, you have a loop, inside the loop, and inside the loop. The inner loop, the mode inner loop is a number of questions. The middle loop, it is a number of parts. And the outer loop, you want to do it again and again for 1 minute. Right? So that's why you see, you have 3 y here. Y, y, and y. They are netted together. Now see, for each of the, if it's a y here, you see, initialize, initialize, do something, that's outer y, do something, have action to change the control variable here. Now look at the second one here, initialize it, compare the, check the condition here, do everything, have action to change the counter here. The inner loop here, initialize it, check the condition, do something, action to change the counter here. So you can see exactly the same model. The 3 loop here, initialize the control variable, check the condition, and have the action to change the control variable. Okay. Okay, so for this one also, we can run it. Here. Đây. Đấy. Number B. CCC. So see. Right here. Part 1, 1, 2, 3. Part 2, 1, 2, 3. Right. Part 3, 1, 2, 3. Part 4, 1, 2, 3. Part 5, 1, 2, 3. 2, 3. Same. Okay, so I think it's short. I take a short break and come back in 12:30. Any question? Okay, so if you look at pseudocode here, so I do hope that you have to pay attention on pseudocode. It's very helpful when you work with debugging exercise here, right? So see, it follows exactly the same structure here, right? Housekeeping here, the while loop here, right? Housekeeping here, get the quick name, right? And check the condition here and do the detail loop. You see, in the detail loop, you have the netted inside the loop, right? See, that is the inner loop, every question here, right? That is the outer loop here, every part here. And again, you see, structure always the same, right? In the inner loop here, before the loop, initialize the counter, right? Do something and change the counter here. In the outer loop, initialize the counter, right? Do the loop, everything, change the counter variable here, right? So if you look on this one and if you understand the logic of this one, it's very easy for you to do with the debugging exercise here. Right? I want you to pay attention, to pay focus on this one, on the pseudocode on this one, and to understand what you are expect to do with the pseudocode here. I said, if you look on this one, if you look on the flow chart also, what you expect to do with the debugging exercise, number 4, and number 4 normally is a flow chart, right? You have to expect to do with this one here. See, main line logic Hands up, you have the skill. Now, netted loop facts. Netted loop never overlap. That means if you netted, you have to put the one loop totally inside another one. Never overlap here. And the inner loop go through all of its iteration each time, and each outer loop go through just one iteration. We can go back to this one here. You can go back to what is this one here. In order to print out, right? You see, you have to print out everything from 1 to 3. 1 to 3 is the inner loop, and you increase the iteration for the outer loop to only 1. I see. You have to do everything, every iteration of the inner loop first. So when you done it, you move to the next iteration of the outer loop. And the total number of iterations is equal by netted loop is the number of inner loop iteration times the number of outer. I think about this one, right? You have each part, you have the 3 questions, and you have 5 parts. So total iteration is the 50 here. Now, avoiding common loop mistake. And if you look on this program, what do you think? What's wrong with this program? If you look on the flow chart on the left and the pseudocode on the right, what's wrong? Yeah, right. Remember, you have to follow the rule. Initialize the control variable. And what is the control variable for this one? Name. You see, if you look on this one here, that is control variable, right? So that's why basically for this one here, you have to initialize variable before the loop and outside the loop, right? So basically for this one here, basically for this one, this one you need input here, name, right? Before that is the initialize variable before and outside the loop. So in order to have something to compare here, otherwise you got a syntax error. The same with this one, you need to input the name here. So now, I hope you understand about the logic of the flow chart and the pseudocode here. Once you understand it, very easy for you to do with the pseudocode and the flow chart here. The same with this one. What's wrong with this one? What's wrong with this one here? What's wrong with this program?
Changing the
You already initialize it. You check the condition, but the first step you need to change the answer of the control variable here, right? So the control variable here is a name. That's why you need to input the name and you put input name here. And the name here actually is the name of next customer here, right? And you do it everything. So see, it follows exactly the same mainline logic here, right? Okay, so see, just remember about the structure here. Initialize the variable, control variable before the loop, and check the condition and have the action here to change the control variable here. Okay, now avoiding a common loop mistake using the wrong comparison. The wrong comparison, right? Think about if you look, if you go back to this example. Mouse. Okay, nothing but this one. Okay, so the comparison is that you have to pay. We have to pay attention for this one, right? So now what happened here? It's that exactly what is here. Wrong mistake about the combination. So for this one here, right? If you look at this one, the condition here is always no, right? That's why you keep doing it forever. Even that you have to initialize the counter and you have the action here to change the counter. But the condition here is never ever true, right? So it never, yeah, that's why you keep doing it. So this one here. You see this one also. It is ended loop. Even that you follow the same structure here. You initialize the counter, you check the condition, and you have something to change the counter variable here. Right? So that's why the condition here is also very important. You have to make sure that you have to put the condition that somehow it must be real here. Right? Otherwise, we have the problem with the loop here. Okay, so programmer must use the correct comparison. That's one, right? And seriously depend on action performed within the loop. Overcharge insurance customer by 1 month. Right? I think about instead of print out the hello 10 times, we do it 11 times. That's what's the thing, right? Overbook a flight, you have many problems with the loop here if you do not plan it correctly. I think about this one also. That is a mistake here, right? So instead of comparing if the name equal to a quit or not, you use the name greater than quit. Not correct. Right? Don't do that here. Some of the common mistake here. A common mistake includes a statement inside the loop that belongs to outside the loop. So what is it? Example that discount every item by 30%. Now, so if think about here, you have think about this program here. This is a simple program here, right? So think about you have the item for this one here. You think about this program, you have number of items. You have the what is it? Item. Okay. You have many items. You think about that. You have the item number. You have the for each item. You can think about you have the code for each item. Right? You have the code number 1 for the first item. You have a code number 2 for the second one. You have a code number 3 for the third item. Now, for each of the item, you have the number of quantity. Right? Think about so for the code number 1, you might have the 10 item. For code number 2, you might have a 15 item, and your code number 3, you might have the 20 item here. Right? So this program here. This program is that asks you to print out the updated price. Right? So think about each of the item that you have the discount 30% here. Each item you have the 30%, and you have to print out the new price and stick into each of the item here. Right? So okay, think about this one here. This program here. Now think about you have the discount the 30% for every item. For every item, right? So think about it. When you do the 30% for every item here, you have to take it out of the loop. Do it one time only. I think about this one. You just print it out. You figure out the discount price out of the loop instead of doing again and again for many items. Right? Okay. So now think about this one here. And you have the code number 1. Code number 1 here. The original price is 100. Right? And you have the 10 items for that. Right? So now you see, you have to figure out the discount number here. You have 30%, so we have the 70 outside of the loop. So after that, you print out 70, print out 70, print out 70, print out 70, 10 times, give it to the item number. Instead of take 100 here and figure out the 70 for each of them here. All right? You got it? Yeah, I think that's the case here. How can I do it? Now let me give you the other example here. It's very straightforward. Let me give you the other example. You can see what the. I can think about this one here, right? I can think about if I want to figure out the sum and average of the 10 number here. I think about how. So for this one, I had the loop. How it's a 10, I stop it. And for this number, remember that whenever we work with the sum, you have to initialize the accumulator. I put the sum 0 here at the beginning. Right? And for each iteration of the loop, I increase the accumulator by sum equal the new sum equal to old sum plus the number, the counter. And it's at the end of the program, as we know the sum. Okay, so the thing about that is that very simple example when we work with the loop. Some of the most common application when we work with the loop is that figure out the sum. Now think about this one here. I want to print it out the sum from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So how we do it? I initialize the sum. They call it an accumulator. So I explain what accumulator before later. So accumulator, I initialize 0. So now for each iteration of the loop, right? You see, I have the sum equal to the sum plus count here. So what happened for the first iteration? The old sum here is 0, right? And I plus the count number 1. So the new sum equal to 1. Right? So now I move to the second iteration. So the new sum equal to the old sum is number 1 here. Plus to the count here. Right? That's why I have the 3. That's why they call it accumulator. Remember when you do the sum, you have to initialize the accumulator before the loop, outside the loop, and put the 0. And for each iteration of the loop, add it to the number here. Right? So now think about this one. Now let me see what is the sum here. And of course, this one you have to change the variable here, right? Otherwise, I need to count the one. See, you have the one. You have let me run it step by step to see how it works, right? Now see, you have the sum 0 here, right? See, at the beginning you have the sum 0 here, right? Now, sum now move to the 1, right? Move to the 1 because 0 plus 1 is 1. Now do that. Sum now is 3, right? You see, it's accumulator here, right? And do it again. So this program work well. In the case I want to figure out the sum here. I want to figure out the sum here. Now think about this one. I want to modify my program to figure out what is the average. Right? What is the average over the number here? So I can do it, right? And you know that in order to figure out average, you just take the sum, you divide by the number here, right? By the how many number here, right? So I can change it here. I can modify my program. I have the sum here. Sorry, average equal to the sum divided by count. And of course, the last thing I just print out the average. Okay, so now what happened here? Let me run it. Okay. You have the 10 number. The sum is the 55 and the average here 5.5. It's correct, right? It's correct, right? Agree or not? Now, but you have problem with the program, right? Now, you see, in order to figure out the average, you just need to do it one time only. Why do you have to do it again and again and again for iteration here, right? You see, for this one here, for each iteration, you do the sum and you figure out the average here. Now, see, you can see it here. You can clearly see by I put the okay. So see, instead of doing it on one time only, why do we have to do it again and again and again inside the loop? It not make sense. It slow down process, right? So that is the thing. If you know that something belong to the outer loop, move it to the outer loop. Sorry, belong to out of the loop, move it to outer loop. Do not do it inside the loop. It slow down process, right? Slow down process. The same with this program here. The same with this program, right? If you know that for each object item, that doesn't matter if you have the 10 item or 100 item, everyone has the same price and everyone has the 30% discount here. Do it outside the loop. Don't do it for each iteration of the loop here. Right? Make sense? Okay. Okay, so you can see for this one here. Detail loop here. Detail loop here. I see. For each of them, I have to do it again and again and again and again. Right? Again and again and again. So instead of that, I just move it out outside here to make it way better for the program. Right? You can see for this one. So we do the same. 100 here. Okay. So for this one, you see, I have the one sticker here, right? I need to print out one sticker here. I need to print out the one sticker. Original price 100. Right? So each of them will be the 70. Right? So now instead of doing one time for 70 and I print it out for 100 times, for this program, you see, it's not equal, right? You see, for each program, you do it again and again and again. See, when you move here, you do it again and again. Really slow down program. Make sense? So now, if you know for sure, it is out of the loop, move it out the loop. Do not do it again and again and again. Same with this one here. It's the same with this one here. I see. You can move this one outside. Yeah. Move this one outside. Do the same. Right? Do the same. So instead of doing for 100 times, you do it for 1,000. Right? Okay, so see, don't do it. Don't do it. Move it outside the loop. Move it outside the loop. Okay, so see, don't do it. Move it outside the loop. I see. Move it outside the loop here, right? Instead of put it inside the loop. This one. Now, so basically it. Okay. Now, so far we work with a while loop, right? In while loop, you know that you have the condition to check. And in actual, you can in the real programming language, you can use the for loop also. So for loop also we work with the structure quite the same, right? You have initialize, you test it, and you enter it here. So see, For this one here, you have 3 steps, right? On the left here, right? You initialize the count, right? And you check the condition. If the count less than or equal or less than or equal 3, keep doing print out the hello. And remember that you have to action here to change the control variable here. Right? And if you work the for loop here, the for loop will work quite the same, right? You have the for here, count 0, that means it is initial value. Right? 2 here, that is a condition here. That keep doing it until it reaching to number 3. Right? And step here, you can define step. So basically by default, the step is always number 1, but you can define step here. Right? You can define step. So you can define step. If you want to skip it, you can do it 2 or 3 or 4, whatever it is. You can do it 2 or 3 or 4, whatever it is. So you have to understand about the for loop when you work with the pseudocode and stuff. So basically, it works the same, right? It works the same. Initialize here, right? Condition here, and have action to change the control variable. Right? For this one, add 1. For this one, step 1 here. And of course, if you want to print out, think about if you want to print out the even number, right? You have to print out the step of 2. Right? Even number, you see, you have 2, you have 4, you have 6. Right? So in that stuff, you have to put it out there. Sorry, you have to step number 2 here, and of course, you have to step number 2. Right? Makes sense. Okay. So now, ask you to write a program to print out every odd number from 1 to 20. How we do it? Every odd number from 1 to 20. How we do it in the router? How do we? Follow the same rule, right? Initialize the count and check the condition here. And check the condition up to 20, right? Up to 20, that means it's less than or equal to 20. Keep doing it, right? And you have the output. Now you have the output count. And for each of them, each of the iteration, you increase by 2. Right? Okay, do the same. Okay, so you see, you have the count from 0 up to 3. You step number 1, right? You just print it 3 times here. You see, you initialize the count variable to 0. It's actually the same. Sorry. Check the count variable again, limit of 3. The same. So it's true, right? Do something and increase the count by 1 by step by limit. The same when work with the while looping. Again, step value, right? It can be any value. It can be negative, positive. You know, right? Can be any positive, negative, or can be any number of step here. Can be. But by the default, it's always number 1 by step. Okay. And normally for the loop, you have the 2 types of loop. You have a pre-test loop and you have a post-test loop. Pre-test loop, that means before doing every body of the loop, you have to check the condition first. Right? You have to check condition first. If the condition true, keep doing it. If not, exit it. Right? So by the pre-test loop, you see, here. You have a while, right? The condition here, you have the condition. If condition true, do something. If not, you do nothing. So in the pre-test loop, in the while loop here, you have sometimes you do not execute anything. Right? In some cases, you do not execute anything. I think by this one, if you have check the condition, it's not true, you don't do anything. That is a pre-test loop. Pre-test loop, that means you check the condition before you do anything inside the body loop. So in some cases, the loop did not do anything. And you have another kind of loop. It's a post-test loop here. The post-test loop, the loop control variable is set after each iteration. So in the case of post-test loop, the body of the loop will execute at least 1. So it's not execute, and after that you check later. So that's the difference between the post-test and pre-test here. And in the pseudocode, the code is a do while loop here. That means you just keep doing it for at least one time, and you check it later. You see, do pay a bill while more bill remain to be paid here. So in the router you can do it. In the router you can do it by the post stat and pre-test here. You see for this one here, right? For this one here, right? This one here on the left, you need to check the condition before you do the body to look here. That is the pre-test. But this one here, you do something first, and you check the condition later. That is the post-test. And in the router you can do that. You can do with the while loop and the post-test. Think about this one. Okay, so good thing about this one. What do you think about this one? This one is what do you think about this? This one is a pre-test or post-test loop here. Pre-test or post-test loop. If you look on this one. If you look on this one, pre-test or post-test. What do you think?
Pre-test.
Now let me see. Let me change the. I think it should be better to do it here. Should be better. I change the program. Okay. So what do you think about this one? This one is pre-test or post-test here. This one is pre-test or post-test here. This one pre-test or post-test here.
Pre-test.
Yeah, this pre-test, right? You see, after that you just check the condition. After you do everything, something inside the loop here. Alright. So it's a pre-test. Remember that in pre-test, you might have some case you do not do anything. Now what happened here? For this one here. If I run this program, right? If I run this program here, I put no here, nothing, right? Nothing in my output here. But in that case, I do with the post-test here, I modify. Sorry, this is not this program. Why am I over? This one here, I move it to before this one. So what happens? This one will execute at least one time. It will print out at least one time. Whatever it is, you check the condition later. Now, see, do it here. Right? Even I put no here. I do not want. But it's still print out the hello here. Right? So that's the difference between the post-test and pre-test. Remember that pre-test, you check the condition first before you do the body of the loop. So for some case, you do nothing with the loop here. But in the post-test, you do something and you check condition later. At least one time you have to do it. Right? Okay. Okay, so see that is a pre-test, that is a post-test here. And okay, here have a do while loop. That means you do something first, check the condition later. Right? And so while loop here, that is a while loop here. Right? And the initial value, check the value, and do it again. Recognizing the characteristic of share by structure loop, or the structure loop have the characteristic that the loop controlling evaluation must provide either the entry or exit of the structure. Right? So it can be the entry, that means when you work with the pre-tag loop, or exit when you work with the post-tag loop. Right? Right? The loop controlling evaluation provides the only entry to exit from the structure here, and some language support the duality loop, which is a post-tag loop here, but not all of them. This one again, don't do it. It's not structure, right? Don't do this structure here. So basically, you see that is a sequence structure loop here. You have initialize value, check the value, have next step to enter the control value here. You see on the left here, sorry, on the right, right? You have initial value, check the value, right? Do something, and you see here. See here, you have the control value, right? And after that, you have to step to change the control value here. Okay. Common loop application, right? Common loop application. The sum accumulator. It's very common here. Keep doing it, keep counting it, right? So you can think about you enter the number of profit for every day. So this one you have to solve. Right? So one day you have 50, second day you have the 60 and 70 and 40 and so on. Right? So do the average iteration of the loop, and each of the iteration add it up. That's why you use an accumulator. Accumulator, that means add it up, right? For each iteration, add it up here. So, so it's similar to the counter. In the counter, you increase by 1, but accumulator increase by the value here. Right? So think about you have the 50 and 60 and 70 and 40 here. Yeah, that's I already did it with a common equation, right? So I think I want to reserve something for the next class here. Okay, now, so if you want to do with the accumulator, remember, 0 will always the same. Set accumulator 0 outside before the loop, right? And for each iteration here, for each iteration of the loop here, once the variable set is processed, at the end for processing, accumulator is the output here. It makes sense? Now, think about this one here. I change this program, right? I change this program. This one. Okay. Do it here. Again for this one, right? And you know that in order to do the accumulator, you have some rule you have to follow. Maintain and initialize the accumulator before and outside the loop. The thing about we have the sum here. You set it to 0 here, right? You set it 0 before and outside the loop. So now for each iteration, you just add it up the number here, right? So think about this one. You want to count the number from 1 to 10. Again, you see. You have the count number from 1 to 10. You have the sum. Remember, you have the new sum equals the old sum, and add it up to the number of this iteration. Right? So for this one, I put the count here, but it can be any number. It can be, so we think about if you keep asking the people enter the number 10 or number 20 or whatever it is. Right? And of course, you need to change the now just bring down the sum. That's the end. And the end program. The sum. Okay. So now see, follow the rule, right? Initialize the accumulator to the 0 outside and before the loop, right? Accumulator after that means you see for it. No. For this one here, I change the value of accumulator here, right? For each iteration, I just add it up to the count number here, right? That's the second one. What is the third one? At the end of processing, accumulator are the output. Right? So see, when I done everything with the iteration, I put out the output here, the sum here. Right? So see, when I run it again, print out the 55 here, right? Or you can run it step by step to chase down here. See, chase it down, chase down. See on the left here. See on the left here, right? Is that accumulator? Make sense? Hello? Make sense or not? It's very straightforward. For this one, I added up the number by the count, but of course, you can get the input number from user, right? Think about enter the number of today, enter the number of yesterday, enter the number before that, and just add it up together. Right? Okay. So I think that's all for today. Let me check again. I expect that before the class on Thursday, I expect you guys to look it up on the pseudocode and the Raptor program. And if you have any question, you can write it to me on Thursday. It make way better for you. Let me check the. Zachary Baker, are you here? No. Barrow, are you here? Zachary Barrow, I'm here. Yes. Cameron, I'm here. Cameron, are you here? William here. Richmond, are you here? Emiliano, are you here?
Here.
Okay. Riley. No, this is Hayden, are you here? Hayden, are you here? No. Jasmine, are you here? Jasmine.
Here.
Look, are you here?
Yep, I'm here.
Diego here, right? Nick, are you here? This one also. Jose, are you here?
Yeah, I'm here.
Martin, are you here? Shalon, are you here? Nathan, are you here? Aiden, are you here? Okay. So I see you guys on Thursday, and remember that it should be better you prepare everything before the class. You have to read about the pseudocode, about the Raptor program, everything, and you can raise any question to me on Thursday. Okay, bye you guys. Bye bye.